All right, lesson 4C is dealing with inverse functions. You need to remember that two functions are inverses of one another if their composites equal each other. So if f of x is the inverse of g of x, when f of g of x is the same thing as g of f of x. And if you're looking at them graphically, then their graphs would be reflections of one another over the diagonal line y equals x. You also need to remember, although just because this happens doesn't mean they're inverses of each other, but two functions that are inverses of each other, the domain and the range will switch places. So the domain of f of x becomes the domain range of g of x, and the range of f of x becomes the domain of g of x. All right, so we'll look at some more examples of what that means. In order to find the inverse of a function, you have to rename f of x as y. You would switch the x and the y variables. Everywhere you have an x, you would make it a y. Everywhere you have a y, you would make it an x. You would solve for the new y using your rules of equality, and then your new y would become the inverse. So let's look at an example of this. All right, so if you think about our steps again, step 1 was to rename f of x as y, so this becomes y equals 4x plus 2. Our next step was to switch the places of the x and the y, so every y is going to become x, and every x becomes y. And then now what we need to do is we need to get this y right here, the new y, by itself. Okay, using our properties of equality, we're going to subtract 2 from each side. So then we get x minus 2 is equal to 4y. Divide each side by 4. You're going to get x minus 2 over 4 is equal to y. And then your final step is to rename that new y as the inverse of f. So the inverse would be x minus 2 over 4. And that's what we're looking for. All right, let's try that again. Okay, so we're going to take our function. The f of x is going to become y. Every y becomes an x. Every x becomes a y. Solve for the new y. I'm going to multiply each side by 2. I'm using my properties of equality. These guys will cancel out. So 2x is equal to 5y minus 3. I'm going to add 3 to each side. Divide each side by 5. So y is equal to 2x plus 3, all divided by 5. So that would be my inverse. F inverse of x would be 2x plus 3 divided by 5. All right, I think we have another example here. Okay, so f of x becomes y. Square root of 2 minus x. Switch our x and our y. All right, so we want to get the y by itself, so this one's a little more complicated. In order to get y by itself, we need to get rid of that square root, so we're going to square each side, still using our properties of equality. X squared equals 2 minus y. Subtract 2 from each side. X squared minus 2 equals negative y. You need to solve for y, so we're going to divide everything by negative, which changes the order. So f inverse of x is equal to 2 minus x squared. Now this is not completely true. I'm going to come back to this problem in just a second. What we need to do in this case is we need to consider the statement about the domain and the range switching places. Okay, so if you think about this function for a second, if you graphed it on your calculator, it would look something like this. It's a square root function. Okay. All right, and if you look at this, your domain is from negative infinity to positive 5. And I apologize, infinity always gets, or you guys can say x is less than or equal to 5. That's probably how you're used to saying it. All right, your range in this case starts at 0 and it goes up forever, which you guys are used to saying y is greater than or equal to 0. Okay, so that's this function here. Everybody understands the domain is what the x values are, which is from negative infinity until you reach 5. There's nothing over here in front of 5, so that's why we're not going to include it in the domain. The range are the y values, so we start down here at 0 and it continues to grow up forever. So the range is y is greater than or equal to 0. All right, so if we work out the inverse of this, we get y equals the square root of 5 minus x. X equals the square root of 5 minus y. We're going to square each side. X squared equals 5 minus y. So I'm going to get x squared minus 5 equals negative y. So our inverse is going to be 5 minus x squared. All right, so if we look at that, that is, and you put that in your calculator, what you would get is something that looks like, it's very hard to draw, a parabola. Okay? Now, I told you before that in order for two functions to be inverses of each other, then they have to be a flip, a reflection over the line y equals x, and that's that purple line there. So you can't start out with a square root function or something that looks like that red and then end up with the green, because those are not mirror images of each other. So in this process of solving for the inverse, you squared the function, which picked up the other side of it that you didn't want. So in all honesty, we do not want this here. That should not be part of our answer. Okay? So when you give an inverse, you need to say, well, the answer is 5 minus x squared, except you only want it when x is greater than or equal to 0. Okay, and how did I know that? I got that domain from the original problem's range. So the range of f of x becomes the domain of f inverse of x. They switch places. And of course, the range of this would be all numbers less than or equal to 5. And you can see that here's 5, and it's all the numbers less than that. So when you think about, or if you have an opportunity to see the graphs, they have to look the same. It's just going to be a reflection. And all the x's and y's switch places. Notice this has the 0.50. So if we flip those numbers around, this is the 0.05. Okay, those are the same points but on the inverse graphs of each other. So this point belongs to this point, and you could find some other ones. This point right here is a reflection of this point right here. So keep in mind the domain and the range need to switch places. So now let's go back to this problem because the same thing happened. You're gonna need to set a domain restriction, because if you don't, then your answer's got too much in it. So even though it never asked you about the domain and the range, you need to consider it here at the beginning. So this guy right here has a domain of x is less than or equal to 2, because if you get bigger than 2, then you're going to be taking the square root of a negative number. And the range is y is greater than or equal to 0, which means, switch those guys around, this is going to be the inverse only when x is greater than or equal to 0. And you need to include that in your answer, because if you don't, you're going to lose partial credit. All right, so we talked about the domain and the range. What if you are given two functions and you're simply asked, are they inverses? This is where we rely on lesson 4b, and we check their composites. F of g of x. All right, so that means take g of x here, 3x minus 4, substitute it in for the x in f. So that's going to be 1/3 3x minus 4 plus 4. So 1/3 of 3 is 1. 1/3 of 4 is negative 4/3. And then we add 4 to that. You're going to get x. 4 is the same thing as 12/3, so you're going to get x plus 8/3. Okay. Now what happens when I test out g of f of x? That is when we're going to take this 1/3 x plus 4 and substitute it in there. So we're going to get 3 times 1/3 x plus 4 and then minus 4. So 3 times 1/3 gives you 1x. 3 times 4 gives you 12. And then minus 4 is going to give you x plus 8. Do these guys give you the same thing? Nope. So no, they're not inverses of each other. All right, you got to get the same thing. All right, so we've gone through each type of problem, how to find an inverse, how to limit the domain and range of the inverse, that the inverses have to be reflections of one another if you're looking at the graphs, and then how to determine if two functions are inverses of one another using composite functions. All right, so go ahead to the lesson 4b activity, or excuse me, the lesson 4c activity, and see how you do with it on your own.